Hello, and welcome to Spinnaker at Upside. Jeremy and I are very excited to share with you some of the things that we've learned after working with Spinnaker. First, a little bit about me. My name is Christopher Rung. I'm a senior site reliability engineer at Upside, and when I'm not in front of a screen, you can find me either cooking or baking in the kitchen or running. First, I'll review the installation of Spinnaker and how we overcame a few issues. Next, I'll share how we migrated our apps to use Spinnaker while preserving the existing deployment methodology. I'll then pass it over to Jeremy, who will provide insight into how we educated our colleagues about how to use Spinnaker. And then finally, Jeremy will share a pipeline template testing approach that we developed to create sandbox applications. So let's talk about Spinnaker's installation. Spinnaker is ancient, almost 5 years old, and has had the reputation of being difficult to implement because it has so many different components to keep track of. Thankfully, a tool has been developed called Halyard that eases this installation, and my team was very excited to learn about Cleat that's supposed to make this process even easier. Before deploying Spinnaker to our shared infrastructure, each person in the team installed Spinnaker on their local machines using Minikube or Kind and Halyard. But we quickly realized that we were going to run into an issue. How do we collaborate? Thankfully, Halyard's configuration is isolated to one directory, what is known as the how config. Ideally, our how config would be version controlled and not contain any sensitive data. Being the SREs that we are, of course, we developed a Python script to automate the backup of and restoration of this how config. We solve the version control piece of it by storing the how config in a Git repo that also stores all of our pipelines and pipeline templates. We also ensure that no sensitive data is being shared by instead including placeholders for these secret values that's later filled in with AWS Secrets Manager. Our how config script has two options. You can either restore, which will replace your local how config with your team's, or you can backup, which will upload your how config to S3 to share with your team. If you choose to restore, it will download the backup from S3 and merge it with your Git repo, interpolate the secrets from AWS Secrets Manager into those aforementioned placeholders, and use how backup restore to restore your local backup. You can then use how deploy diff and how deploy apply to actually propagate those changes into your Spinnaker installation. If you'd like to back up your local how config to S3, you can use the backup command, which uses how backup create to create the backup, and then it uploads that to S3. This script is available as a GitHub gist, and we hope you think it's useful. When you've reached this point, congratulations! You have a running instance of Spinnaker on your infrastructure, and you can collaborate effectively with your team. Now, Spinnaker has some suggestions to productionize your instance of Spinnaker, and the first of which is to externalize Redis, because the existing built-in Redis can be overloaded fairly quickly. Since here at Upside we run on AWS, we first created a new Elasticache Redis instance using Terraform. We then modified some of the files in our how config, and then applied the change to our Spinnaker instance. After using Spinnaker for a little while, our team noticed that it started to run slowly, and particularly its cloud driver service was consuming lots of CPU. After we looked into it, we learned that cloud driver is what pulls the infrastructure for new information and caches that, and it also is used to run jobs. So after we had a lot of concurrent pipelines running, our cloud driver was working very hard. After we increased the replica count to 3, it really lessened the load on the previous one instance that we had running, And then we also realized greater performance benefits after enabling high availability, which actually shards the cloud driver service into 4 separate services. Finally, we created a new EKS node group called Spinnaker for all of the Spinnaker services to run. We did this to separate all of the Spinnaker services from the rest of our infrastructure. To implement this, it was really easy. We just had to create a new node group using Terraform, and then add those 3 lines to all of the services in your how config. Now I'll review how we migrated from our legacy deployment methodology to using Spinnaker. Now it's important to leave your existing deployment path intact as you migrate your services to Spinnaker. At Upside, we used a Slack bot to call a Jenkins pipeline job to deploy our services to our Kubernetes clusters. We modified this deployment pipeline to first check to see if that app existed in Spinnaker using this handy expression, and if the expression succeeds, then we halt the Jenkins deployment and instead provide a message containing a link to the services page in Spinnaker that the engineer would be able to visit and then deploy their service using Spinnaker. One mistake that we made while we were developing our pipelines is during the run job stages, we were trying to wedge in our scripts into the Kubernetes manifest that was afforded to us. And this made us do some hacky things like include escape characters galore and have the double ampersand to represent each line. And it was very difficult to read. So after we switched to using config maps instead, we realized a lot of benefits. Like the script was immediately much easier to read, especially with syntax highlighting. It made the Git reviews a lot better too. And we could also more easily test these standalone scripts on our local machines before we pushed it to Spinnaker. And I'll leave you with one last piece of advice. While modifying existing pipelines or creating new ones, make use of that Edit as JSON button. Our team found that it was really helpful to map the UI changes in Spinnaker to the pipeline code. But we found that Spinnaker assigns numeric values to each of the stages' IDs, which wasn't very intuitive when we were trying to refer to them later. So we renamed all of those numeric values to something that was more that described the stage better. And that's all the time I have left. Thank you so much for your attention, and now I'm going to pass it off to Jeremy to discuss how we migrated our services to using Spinnaker. Thank you.
Thanks, Christopher. So my name's Jeremy Deppen. I'm an SRE here at Upside. And aside from work, I'm a coffee lover, traveler, photographer, and really just an enjoyer of all things. So what I'd like to talk about in the last half of this presentation is how do we migrate our services from using Jenkins for deployment to Spinnaker for deployment. So after the initial evaluation, setup, and fleshing out of our pipelines, we finally have an MVP, a minimal viable product that we can begin to start migrating our services over to use. So onboarding our services to Spinnaker. It's here. The day is finally here. It's happening. We finally have an MVP and a fleshed out pipeline enough to begin to start using for our lower priority services here at Upside. But unlike this episode of The Office, when the entire office is freaking out over a fire alarm and it's just pure chaos, we obviously wanted to take a more methodical approach to this. So, as every engineer is familiar with, we took the iterative approach. So what we did was, once we had our fleshed out pipelines enough, we onboarded a couple, 2 or 3 lower priority services here at Upside to begin using Spinnaker for deployments. So what we did was we onboarded these services. We gathered feedback from the engineers that were in charge of promoting and deploying those services. And we edited, added, or deleted functionality. And then we repeated this process, adding a couple more services each time. And I believe after 5 or 6 repetitions of this, we had about 40 lower priority services using Spinnaker, and our pipelines were more mature and sophisticated than when we started. So to kind of nail this point home, and it's a bit of an oversimplification, but here's what our first service looked like when we onboarded to Spinnaker. Here's what our first pipeline looked like for that service. So as you can see, a bit of an oversimplification, but hopefully it gets the job done. And by the time our last service was migrated to Spinnaker, here's what our pipeline flow looked like. Again, a bit of a far-fetched example, but hopefully it nails the point home. So before we actually began any sort of migration, we needed to be sure that we communicated with our engineering teams, because of course they're the end users for Spinnaker. They're the ones that are going in and deploying, promoting, and just overall using Spinnaker. So as an SRE team, we had been using and configuring Spinnaker for 2 or 3 months before this, and we were kind of numb to the idea that not everybody knows Spinnaker, which is very obvious to y'all watching. But after working with Spinnaker for so long, we kind of forgot that other people might not know it as well. So what we did was we sat down with each team. We had a live demo walkthrough, kind of some good to know things for what they'll be doing every day, how to deploy, what a deployment flow looks like, how to use our pipelines, and some Q&A with them. And we found that really ensured some confidence in our engineering teams. They became pretty confident with the deployment platform for Spinnaker. So I included a picture here of our 5 pipelines in Spinnaker. So taking a step back, we have about 160 services here at Upside running in Kubernetes. In Spinnaker, each service has its own Spinnaker application. And within each Spinnaker application, that application has 5 pipelines that are listed here: deploy dev, deploy stage, deploy prod, deploy version, and restart. So essentially what the overall flow looks like is when code is merged or PR'd into master for a service, that'll kick off the deploy dev pipeline, which will automatically deploy it to our dev Kubernetes cluster. Then some tests are run, and if the tests deem that it can't go to stage, it'll prompt for a manual judgment. And that's where the engineers come in. They'll go into the UI. They'll either promote that to stage or they'll stop the pipeline at dev. So, and then we have a deploy version pipeline, which is more for one-off hotfixes. So for example, if a team needs to push a hotfix to stage, for example, they choose the deploy version pipeline, deploy version, say 3 to stage. And similarly, but differently is the restart pipeline. And that's more for just restarting pods in Kubernetes. So for example, if a config map value changes and the pod needs to pick up that new environment variable, they'll run the restart pipeline. So we found that really sitting down and demoing the use case, not just the use case actually, but exactly what buttons to press, really helped ensure confidence in our engineers. So as I said earlier, we repeated the iterative approach about 5 or 6 times. By the time that was done, we had about 40 lower priority services in Spinnaker. And now was the time, now that we have a fully fleshed out pipeline flow, to migrate our remaining 120 or so services. So as every SRE knows, everything can be automated. Nothing is too small to be automated, is the joke. So of course we wrote a script for this. We wrote a script called migrate app, as you can see in the screenshot. And essentially what that does is you pass in the service that needs to be migrated from Jenkins to Spinnaker, and it'll modify files as needed in that service's repo to basically say, hey, don't use Jenkins anymore for deployment, use Spinnaker. And it also uses the Spin CLI to save that as a Spinnaker application and save its subsequent pipelines. So what that enabled us to do was be able to migrate 120 or so of our services in about a day or 2 to Spinnaker. So it's over. It's finally over. We have all of our services in Spinnaker. After a few months of hard work, it's finally done. Now we can kind of just push off Spinnaker to the side and work on implementing the next cool SRE tool or functionality. No. It's actually not over. As any SRE knows, there's still a lot to do. There's always more to do. We know that everything can be automated or improved upon. So what we currently have to do still here at Upside regarding Spinnaker is we have a couple questions. How do we automate around encouraging full continuous deployment? So for example, between our dev, stage, and prod pipelines, for the most part, we require manual judgments to either promote or to not promote something to the next environment. We need to begin to encourage our teams, our engineering teams, to write trusting tests to essentially say, okay, it looks good in dev, auto-promote that to stage. Again, not a Spinnaker thing, more so just something we need to do here at Upside, but Spinnaker does help to enable this. Another thing is, how do we implement strategic deployment rollouts? So for example, in the future, we'd like to implement canary deployments. A third thing is, how do we better organize our pipeline templates? So for example, right now, we manage about we have 5 pipeline templates for the 5 pipelines that we just saw. But in total, we have about 14 pipeline templates due to some applications require very small nuanced changes to those core pipeline templates. We'd like to, in the near future, either consolidate that down to one parameterized pipeline template and just a generalized pipeline template, or look into a third-party software for this. And then the fourth thing, so those first 3 things are in the works here at Upside in the near future. But the fourth thing, testing new pipeline functionality, is what we've already kind of solved for. And to take a step back, the problem there is because our 160 services all kind of point towards the same couple pipeline templates, a change to one of those pipeline templates will propagate through our 160 services, which is great and convenient when you have something, new functionality that you know for sure already works, but bad if you push out a bad fix. So what we did was we created a utility here at Upside called Sandbox. Essentially what it does is it just spins up a sandbox Spinnaker application, and I put spin there in italics because we're using the spin CLI for it. So essentially what it does is it creates a sandbox application mimicking our in-use pipeline templates as closely as possible, but uniquely enough to not step on their toes. And so basically what we're able to do with this is if our new changes work in the sandbox application in the sandbox pipeline templates, we know and we're very confident that when we lift and shift that change to our in-use pipeline templates, that everything will work as needed. And this is just an output of the script. So it's essentially just saving our shell script stage jobs as config maps and saving the Spinnaker application and pipeline templates. So again, that just ensures confidence and allows us a nice way to test our pipeline templates. So wrapping it up. In conclusion, Spinnaker has been great here at Upside. It's enabled us to have more complex pipeline flows, given our engineers more control, and helps us to ensure confidence in our deployments. But most importantly is that fourth bullet point. It's helped us to raise the roof. It gives us a higher ceiling to work with thanks to its built-in functionality. And what this does is it allows us to focus most of our attention on delivering actual business functionality. So thanks everybody for your time. My name again is Jeremy Deppen. I'm an SRE here at Upside, and previously speaking was Christopher Rung, a senior SRE at Upside. Feel free to reach out to us about any questions you might have. Thanks.